In 1997, a fire began in Indonesia that would rage for almost a year. It spanned several thousand square kilometers, halted numerous international flights, and spread an acrid haze all the way to China. Yet despite being one of the largest fires in recorded history, for months at a time it burned without a flame, blazing on entirely underground. This might sound like a uniquely freaky fire, but each year subterranean fires produce roughly 15% of global greenhouse gas emissions. That's 6 times more than international aviation. And these burns are virtually unstoppable, earning them the ominous title of zombie fires. So, is it possible to snuff out these bizarre blazes? And how do they even form in the first place? A standard fire requires 3 ingredients: fuel, heat, and oxygen. Every fuel has what's known as an ignition point, a temperature at which it begins to break down. This process, also known as pyrolysis, releases gaseous compounds that mix with nearby oxygen molecules to produce combustion. And it's this chemical reaction that releases large amounts of heat and light in the form of flames. But not all combustion leads to flames. Pyrolysis leaves behind a solid material called char, like what's found in charcoal. Char contains no combustible gases, but it's rich in highly flammable carbon, and under hot enough conditions, its surface reacts with the surrounding oxygen, creating a slow, glowing burn called smoldering. Instead of flame, this process releases smoke. Specifically, smoke full of emissions like carbon monoxide, methane, and particulate matter. All these factors come into play in zombie fires, which are more scientifically known as peat fires. Peat is a type of soil that forms when organic matter builds up more rapidly than it decomposes, and it's typically found in regions that are very cold or very wet, 2 factors that can slow down decomposition. When plants shed and die in peatland, the carbon they've absorbed during their lifetime gets locked inside, making peatlands one of the planet's largest natural carbon stores. But just like char, that also makes this carbon-rich material extremely flammable. Historically, the moisture and cold temperatures of peatlands made them unlikely to catch fire, but today, droughts caused by climate change are drying out these landscapes worldwide, and other peatlands have been drained to make way for farms. Under these conditions, a fire at the surface can more easily ignite the peat below, transforming it into char, which will continue to smolder. As heat builds in the soil, it further dries the peat, and eventually, deeper layers begin to burn. Peat fires are slow, creeping along at just 1 millimeter a minute. But what they lack in speed, they make up for in persistence. These fires can burn for months or even years, all while spewing smoke full of poisonous gases. And since they show few signs of burning above ground, they're incredibly difficult to track until they ignite dry surface soil, potentially miles away from the source. Zombie fires can even burn beneath snow-caked soil, overwintering until they spark new blazes in the spring. So how can we fight these fires? Well, dousing them with water is surprisingly tricky. Water's molecules form close bonds, resulting in a high surface tension that stops it from filtering evenly through burning peat. Researchers are experimenting with ways to reduce water's surface tension, allowing it to permeate the simmering soil. And some countries are trying to stop the fires before they start by running controlled burns in peatland habitats. But many others are simply working to prevent peatland drainage, which keeps these landscapes wet and resilient to fires. Despite accounting for only 3% of Earth's land, peatlands hold more than a quarter of the planet's carbon. And as climate change continues to increase the risk of extreme weather, including the droughts plaguing these landscapes, keeping that carbon out of the atmosphere has never been more important.